This is the Bro and Sis Show. My name is Hilary Jacobson. My area is lactation, maternal and infant health. And my brother is here, Eliot Jacobson. He's a professor of mathematics. And we are here today to talk about our ongoing discoveries and conversations regarding what's happening with the climate and the weather around the world. My brother Eliot on Twitter has begun using his professorship expertise to really educate us about what's happening with the climate. I asked him to come on and share it. And here we are.
So, hi, Sis. Thanks for inviting me on. And I can talk about whatever you want. Let me just say, just for the people out there who go, who is this guy? What are his credentials? Essentially, my credentials are just a background in science. I was a professor of mathematics, professor of computer science, and I had a lifelong interest in meteorology. That was actually when I started going to college, what I first thought I would become. And I did run a meteorology program for a little bit when I was professor of mathematics, their undergraduate program. So at the very least, I can understand a lot of what these experts are saying. I'm not actively working in the field, but I'm capable of understanding, digesting, and sort of spitting out to the Twitterverse or whoever wants to listen some of the things I've learned along the way.
Well, what I found watching your Twitter feed was that you were using images and explaining the images in a way that I hadn't seen before. And it made a lot of sense to me. I guess most people learn through images, and there's very little of that I've seen in the climate science. It's been explained in a way that the layperson can really grasp it. So I've really appreciated the way that you've used the maps to explain the basic principles of what's going on right now in the world of climate.
Right. Well, yeah, I kind of looked at, well, let me just say this, Twitter trained me. So I started out with a lot of words and then realized quickly that dramatic images got a lot more attention. And so I would start with the image, and I sort of know where on the internet to find them. And then I would think, what is the right caption? So if you think of sort of writing poetry or a little news article to go with an image that really pulls people in. And you can never give the whole picture with just an image and a couple hundred characters. So you really have to condense what you're thinking. And I write and rewrite. But yeah, let me just, if you want me, I'll share some images with you and then we can just go through some things. And
yeah, that'd be great.
Along the way, I'd be more than happy to do that. So this is my current favorite image that I've posted many times. And this one just talks about where we actually are today, temperature-wise. So a lot of people don't know exactly where this started and how much temperature change we've gone through and how this gets measured. So what we see here in the black line that you can see happening is the best estimate of the average temperature for that year that's going on. And this gray period above and below it, that's sort of what's unknown. So if you like, that's a margin for error. And the closer we get to contemporary times, the less of that gray area we have, the more certain we are. So we became relatively certain about global temperatures, roughly starting around 1850. And so right now, the period from 1850 to 1900 is the baseline. If you sort of average the global temperatures over that 50-year period, and use that as the baseline for the pre-industrial era. Although technically the industrial era started in 1750, if you use 1850 to 1900, then you can really see this dramatic rise we've had. So this little red dot here that I put on the screen is roughly where the pre-industrial era started sort of officially, if you look it up on Wikipedia, around 1750. But the actual measurements are 1850 to 1900 as a baseline, and you see much less of that gray sort of unknown area in that. And so what you'll find was that this 1750, in fact, most of this period from about 1400 up until about 1800 was in what's called the Little Ice Age. So anytime somebody specifies a baseline temperature that's sort of before 1850, what's going on is that, first of all, we didn't have accurate global temperatures. So there's this huge margin for error. Second, we were in this little ice age. So temperatures are just colder. I mean, if you want to go back historically and have a baseline, you could go back to the year 200, and you see there we have much less climate change if we use some era back here as our starting point.
Right, I see that.
Anytime.
Oh yeah, you can really see how it dips down there. It dips down from that sort of average period before 800, 1000, and then it sort of, we don't really see it warm up during the medieval warm period on this graph in particular, but you do see that dip into the little ice age, which meant that, I mean, many parts of Europe were covered in ice, I know.
Right. And by the way, this medieval warm period, that does specify just Europe and that part of the continent. So it's not a global impact.
See.
Right. So that is sort of a documented period where at least Europe was warmer, which is where we have
Eurocentric climate.
Yeah, it is. Whereas the little ice age is really a global phenomena that we're talking about, because we're better equipped to get global feedback by then, because roughly we knew about the whole planet by then.
Can you explain why you say that the industrial age started at 1750? What exactly started in 1750?
Well, it was burning fossil fuels for industry. So in particular, well, let me just say burning CO2 releasing matter for industrial purposes. So if you think about burning coal or wood for a train, for example, right, that would have been the sort of very early use, you know, the steam engine that had to burn some sort of fuel in order to propel itself. We started getting energy from fuels to drive engines in industrial processes. And that, so if you actually look it up on Wikipedia, they do sort of talk about 1750 as the beginning down to the year of the industrial age. That is sort of the pre-industrial breakoff point. Whereas if you want to talk about global average temperatures, it's really important to sort of start 1850-ish, just because we want to know that our temperature measurements are accurate. So what happened is prior to that, they have to look at sort of fossilized climatological records. So whether it would be tree rings or some other artifact of a warm or a cold or a wet or a dry climate, you can find those in historical archaeological records, right, of matters but you can't find people who are actually recording a temperature.
So let me interrupt you for a moment and ask you a question. I've been, if you look at historical records going back thousands and thousands of years, hundreds of thousands of years, you'll see radical ups and downs in that graph. But here you see at the very right edge of that graph, you see that strong upwards thrust, as it were. And what I've heard is that it's not the fact that this has never happened before, but that it has never happened at this speed.
Right, exactly.
And actually at the same time, with the environment that we have today, with all the having to support so many billions of people, having to deal with our toxic, our trash and our fumes. And so we're in a very unique period. It goes beyond the fact that we have reached this temperature. It has to do with the whole theater of how we're getting here.
Yes. And so what you're talking about is this little part right here that I've sort of highlighted in blue. Yeah. So we're talking about a change. So people will often give you the counter argument that climate change, well, the weather also always changes. It's the weather. That's what the weather does. It changes. Well, yes, the weather changes, but it never changes this fast. In fact, the amount of CO2 we're adding every year to the atmosphere, whether it's 3 or 4 parts per million that's going in, is sort of the equivalent of what used to happen over a period of 100,000 years, that we would get that much sort of natural addition of CO2 through processes and gradual changes. So it's really how quickly things are changing. It isn't the change itself, because the Earth has gone through these sorts of levels of changes before, but those processes of change have been very gradual. They haven't been this fast. And so what we're really facing here is just how fast this is happening. Just this system. I have
another question for you. I'm going to interrupt you.
Balance here, and that's the problem. Is things are so out of balance. We're not sure where we're heading. Honestly, we're just not
that's
sure.
Exactly what I wanted to ask you. Another image that you often show that I find is so interesting is something that explains kind of, I don't know how to express it, you do it so well, but it's the earth as a battery. So when I think of a battery, I think of two poles and there's a flow between them, and you have to have those two poles intact. And if you don't, the whole thing just screws up and it doesn't function anymore. And in a sense, on the planet, we have those two poles, the Earth, the North Pole and the South Pole, right?
Yeah.
And then in between that, we have the hot zone that is kind of kept in check by those two areas, right?
Right.
And can you show us something and explain what's happening to that now?
Yeah, there is this idea of a polar jet stream, right? Which is sort of this very high speed, high altitude wind that circles the pole. And what it does is it's a dividing line between the very, very cold polar air and the warmer, more humid, moist tropical air, right? And so what happened is that as the planet warms up, the Arctic is warming up much faster than the equatorial region, some 3 to 5 times as fast.
So the top of the globe is warming up faster than the middle of it, just to bring it down to very simple terms.
Right, and there are several reasons for that. One of them has to do with the fact that it's losing ice, and because it's losing ice, it doesn't reflect as much. Open blue water absorbs more radiation than shiny snow. And so it just absorbs more heat up there.
So the way that I understand it is that you have that ice pack, and everybody knows that if it's hot outside in summer and you're walking barefoot, I mean, I know this from our teenage years, Eliot, and you walk on the white lines, it's much cooler than when you walk on the dark surface of the asphalt. So when you had that block of white at the North Pole, it was reflecting a lot of light, and that kept the area cool. And as it melts, you have more and more of like that dark asphalt, right? That dark area that absorbs the heat, which then makes more ice melt, which then makes the other areas hotter. And so it's like a vicious cycle that won't stop. You have like a heating up system, and it's not clear how you can regulate that and reverse it.
Exactly. It's a feedback loop, in other words, and where we're heading ultimately will be an ice-free Arctic. But along the way, what we're running into is because we have a decrease in the gradient, there's not much difference in temperatures there used to be between the pole and the equator. So this polar jet stream that used to be locked in place is now going through this sort of deep wave pattern. And these are actually called Rossby waves. But these waves, these patterns actually get very stable when this gradient is broken down. So it's not like just the Arctic jet stream is doing all sorts of crazy things. It's actually locked in this sort of new pattern. What happens is that if you think about the cold air at the pole, then it can dip all the way down in one of these troughs, right? Which is why Texas had this amazing cold spell last winter. On the other hand, if you're underneath it, then you have the tropical warmth going all the way up into Canada, right? It's being swept up into Canada. And so what we get are these incredibly hot areas next to very cold areas, next to very hot areas. And if we actually look at the planet, this is a map just from today that shows what's called the temperature anomaly. So this is how much above or below sort of the average temperature a given area is. And if we sort of look at this polar region at the top, then you notice we have a hot area followed by a cold area, followed by a hot area, followed by cold and hot, right? And you can just go around the whole Earth that way. So you can see, you can actually see the effect of this polar, these waves and in the jet stream, and how that's impacted large areas of the planet. And so we have another hot spell going up in British Columbia up here. It's not quite as bad as the one that we had last month, but it is really brutal. And also here in Siberia, we have the same thing. But then also we have the same encroachment of this hot area happening throughout. For example, Turkey is having massive wildfires right now. Iran just had a day that was well over 120 degrees. I think it was closer to 125 degrees. And then we have the same thing happening at the South Pole as well. So you can see these very hot and then cold and hot and cold and hot and cold as you circle around. And so we're getting encroachments. For example, Brazil just got these freak snowstorms all the way up.
Can you show us Brazil on the map for those of us who are
Yeah, so Brazil is right here, right?
Yeah, so Brazil is like a tropical.
Well, it has colder areas to the south, but I mean, it has a huge tropical region, right?
Yeah.
And where they grow coffee, for example. And some of the coffee, I mean, it started snowing it hasn't snowed since the 1950s in that part of Brazil. And all of a sudden we have a freak snowstorm. So what happened is one of these incredibly cold areas sort of peeled away and went north in one of these waves. So, we're just getting freak weather like this, incredibly hot and dry and wildfires, or we're getting floods and cold weather, like in China here. We had this thing happen in China with these floods. Can
you show us China on the map?
So China is right here.
Yeah.
Yeah.
And it's been incredible. It's been tragic. I mean, there's been tragic flooding, not only in China, but in India.
Right. I have a nice slide that I saved from a couple weeks ago when these floods from the 20th of July which is when they had these catastrophic floods in China. And what this tells you, this particular image tells you, is how much moisture is in the atmosphere. And one of the things as the planet heats up that is true is that every 1 degree Celsius rise in average global temperature corresponds to roughly a 7% rise in the capacity of that same air to hold water vapor.
So the warmer it gets, the more it can kind of suck up and hold moisture.
And so what happens then, if we're at 1.2 global rise, that's about an 8.4% increase. So the atmosphere takes up all this moisture, but then we have these waves.
Oh, wait a second. So that means that it picks it up. That means it takes it from places, and then you have drought, and then it puts it in other places, and then you have floods. Is that right?
Well, it's sort of like what we think of with these waves, right? So if you think about an atmosphere holding moisture and then one of these cold waves dipping down, bringing cold air, well, the colder the air becomes, the less it can hold that moisture. And so when this moisture interacts with the cold air, you'll get these storms happening. And so there are currents moving things in all sorts of directions all the time. But you think about this equatorial superheated air being brought northward by one of these waves, interacting with some colder air coming down, from the north towards the south. That's
right. They were kind of meeting each other.
And this purple area right here, and let me just see if I can't get the spotlight for you. So this purple area right here corresponds to some of the floods that were going on in China, right? And actually, if I want to be specific, it's this little area right here that I'm sort of circling right now, which is where you saw those horrific floods in China. And this other area, was in India and Bhutan and other countries in that region. They also have the same floods. It's just they didn't take place in sort of a first world corporate industrial city. They took place in farmlands and rural areas. So you could find images of things floating away there as well, but it just didn't make the news. And we're still getting these floods internationally right now, but you can just see all of this purple, super moist air. And just to put it in perspective,
that's what was happening in Europe last week.
Yeah, that's what happened in Germany, and that's what happened in the UK. They had a freak downpour there. But just to put it in perspective, you see this little area here I'm circling. This was actually that cyclone. I forget its name, FA or something like that. It was a cyclone that was just coming towards the coast at this time. And you can imagine how much rain is in a cyclone. And then you see that these other areas have just as much rain as a cyclone does.
Wow.
You know, and that gives you some perspective for just how wet that is and how destructive that is. So yeah, that is one of the effects of the heating atmosphere, is this ability to hold more moisture.
So I thought that was very poignant what you just said when you said that we heard about the flooding in China because it affected large cities. So, that we care about because they've got industrial production, et cetera, but that the flooding in India hit rural agricultural areas and therefore was less in the news.
Yeah.
And that's really tragic. We don't know a lot of what's going on in the world simply because it doesn't affect, if it doesn't affect us financially, it doesn't really come in our news.
Well,
right?
Let me just give you another example of that, because I mean, this is to me a terrifically sad thing that is going on right now. These are fires that are taking place. Well, not entirely fires. Wherever biomass is burning. So if you think about, there are some power plants that are burning trees also, right? Yeah. But what we have here is essentially the thickness of the smoke on a worldwide basis. And so we can see pretty clearly the up here, the fires that are happening in British Columbia and California and Oregon. And I think you and I are both aware of these because we're both on the West Coast, right? So we know about these fires. And you can see the smoke sort of trailing across the country. And there've been images all over our news every day. We see images of these smoky cities in New York and, but what we don't hear much about is that Siberia is on fire, right? Because not many people live in Siberia. But
when you think of Siberia, you think of permanent ice and freezing temperatures, and you think of the gulags. Don't think of a vast area that's on fire.
Yeah, and it's just so much larger than anything we could sort of comprehend from a US perspective or a European perspective. I mean, you just look at that area that's colored in red there and understand what that means in terms of smoke. And the problem with smoke is not just that we are releasing carbon dioxide and other gases into the atmosphere by virtue of this burning. It's also that is particulate matter, and smoke tends to settle fairly quickly. And you see that it's going northward from there, right? So where is the smoke going to settle? It's going to settle on the ice, which will once again decrease the reflectivity of the ice, as you were saying earlier, right? Which is going to make that ice less able to reflect incoming solar, which is going to make that ice heat up faster, the Arctic heat up faster, and that ice melt faster. So the tragedy is one for all humanity that Siberia is on fire. And the other area I want to just point out, because again, we are so ignorant of what's going on in the world, is look at this. This is the Democratic Republic of Congo and neighboring countries, right? It's on fire. It's absolutely on fire. I mean, compare that to the Brazilian rainforest that's being burnt for just ordinary deforestation up here, right?
Right.
That's what I'm circling. This is massive, massive fires going on in Africa. We haven't heard anything about that. I mean,
this is the first I've heard of it.
Yeah, it's not, I had to, after I saw this picture, I had to go online and start Googling to try and find even where this is and who's reporting on these fires, because essentially nobody is reporting on them. I saw one brief video where they showed these firemen, essentially they had to abandon their fire trucks and they were driving away as fast as they could because they simply could not battle these fires with the equipment they had. And they were in full retreat. So yeah, I mean, this is typical when you talk about a global thing like climate change, where we are so fixated on what's happening right around us, instead of the whole planet.
Yeah, and when you explained it like this, it just makes so much sense how the North Pole is warming up. And, it's not like our governments are reacting logically. They're planning ship routes, right? Through the Arctic.
Well,
They're planning.
there certainly is some of that going on. Again, I have a nice slide that just sort of illustrates what's going on here with that. And I'm not sure whether this is coming through right now or
I
not.
see it.
So this is the sea ice that's left this year in the Arctic. And we are at about 7 million square kilometers plus or minus right about now. But what we can actually see in this picture is the sort of an opening that we can almost squeeze through, right?
Right.
So we should have a fully open shipping channel coming here fairly shortly if it doesn't already exist due to icebreakers having sort of cleared the few areas that remain. But what is really scary about this?
Can you explain this to me? What is it that we're seeing here? The blue area and the white area. What is that exactly?
So the gray areas are land masses. So Russia, Alaska, Canada. Right. And this is a polar view. We're looking down on the planet from the North Pole, straight down onto the North Pole. The blue areas are open ocean where there is no ice. They're just pure open ocean. And then the white areas here are areas where there is ice. And the deeper the white color you see, sort of the thicker the ice is at that point. So what we see here is very thick ice in certain areas, but very thin, bluer ice over here towards the coast of Siberia.
Right.
Of course, it's where that fire is raging right in this area right here, right?
It just seems to me there's so much disconnect to think that, to kind of look forward to the diminished ice as a financial opportunity and to ignore the fires that are happening due to the diminishing ice.
Well, yeah, there is a bad sort of end to this story, of course, which is as these larger and larger areas become open ocean, the water around here superheats. There's nothing sort of tempering that water and keeping it cool or cold, so that come this coming winter, less ice is going to form in that region. It's going to melt earlier in the year. And so after a couple of years, and some people are predicting as early as 2023, it is likely that we have more or less this entire ice pack gone in the Arctic. And it reaches its minimum in mid to late September. It sort of melts throughout the summer. So when we get to that point in mid to late September, we have almost no ice left. That really is the beginning of the end for really the planet, civilization, humanity. I was just reading something today where they're sort of talking about if we want to maintain our sort of industrial, capitalistic, consumptive lifestyle, we're going to have to find a way to refreeze the Arctic. And they are actually talking about trying to seed the clouds up there so that there would be sort of more precipitation to create more ice so that we can have more Arctic ice, during the shorter and shorter freezing period. It's just a crazy idea, but I mean, the people who really want us to sort of keep going with what we're doing are saying we need to create ice. And yeah, because once we don't have ice, then weather patterns worldwide are just going to freak out. I mean, we haven't seen anything yet, right? We're at 1.2 degrees heat. We could go up to 3 degrees global heating in a matter of a couple of years if that ice melts, because essentially that is the freezer, the refrigerator, the air conditioner for the planet, is that ice at the North Pole.
That all sounds very dire, so I don't want to talk about it too much.
Okay. Well, we could not talk about it with a smile on our face.
No, because first of all, I just want to really understand what we're looking at. What I see a lot of is, people thinking that what we're seeing today is just an anomaly. So for instance, we had so much heat in Oregon this year that we had to turn off the water to the agriculturalists. So there was just no water for it. Now we're facing fires and You know, we don't have enough resources to combat the fires. We have the largest fire, I think, in history now going on in Oregon, in the east by Klamath. Yeah. And, you know, and they're talking about how it could become a fire tornado, which would just be another level of calamity. So what happens if this isn't an anomaly and next year we have another year of even worse drought? And what happens to the production of food all across the United States and in Brazil and in Europe and in China and India with these unpredictable weather patterns? Is there any way that we can adjust quickly enough, move our crops, create new water sources, create new food sources? What will happen to the insects? What will happen to our bees that are already decimated? What is the origin of the songbird disease? You know, I mean, that's just nitpicking because there's been rapid death of species now for decades.
So that's a big question. So what will happen? Can we adapt fast enough? Well, humans can adapt fast enough. I mean, humans can run to a place that has a climate that is still within survivable limits. However, the local ecosystem, which consists, like you said, of the bees and the insects, the bacteria in the soil, right? The plants that have adapted to that area, and all the other parts of an ecosystem that can't go somewhere else, right? They will eventually collapse. And we see ecosystem collapses happening, whether it's the massive red tide or manatee die-off that's happening in Florida, or it's the coral reefs that are dying off of Australia, the Great Barrier Reef, because of ocean acidification. You know, we are having right now ecosystem collapses happening in regions that are not small, right? We're having these collapses. So it's not going to be like you'll wake up on a Tuesday and now every ecosystem is collapsed, but we are going to have more and more climate refugees, right? People running or trying to move to some place that's still survivable. So that is going to be the first thing that comes of this, right? Is this massive movement of refugees. We don't want to have people dying and starving and all the horrible things that are going to happen. But that's what's in the cards for the first impact we see. And that's already happening in some places. I don't have specific references right now, but I know in the last few days, I've seen articles about food riots or water riots, you know, happening. And you could say, well, that's always gone on, right? That's always happened. There have been this sort of problem with famine in certain parts. But now the specific cause of that famine is not war, right? It's not neighboring countries trying to steal each other's stuff. It's that entire ecosystems are dying, right? And that's why people are starving in regions. So you mentioned water. So if you actually here in California, just north of San Francisco, essentially there are entire cities that are out of water now. I mean, just gone, just zero water. And I've read about Healdsburg and other places around Santa Rosa, up towards Eureka, Fort Bragg on the coast there, completely out of water, just no water. So what do you do if, you know, it's not just that you're a farmer, you know, who can farm, you can't drink. There's, you know, and they're actually outlawing bringing in tanker trucks of water from places that have water, because those places need that water, right? And, you know, another ecosystem that is collapsing are the salmon here, because the rivers are too shallow, and because they're shallower, they're heating up faster with the excessive heat. And so, you know, we're losing all our salmon on the West Coast. So yeah, we are already experiencing it. It is not something that is going to happen. It is something that is happening. And it's just not going to be all one thing that happens on a Tuesday, right? And it's just where we are. It's that's
right. Yeah, it's where we are. I really appreciate that you were able to illustrate to me using these images and these descriptions in a very simple way, giving me the kind of the global overview of what's happening with the climate. So now I can understand it. And I think a lot of people want to understand it and they can't. So you start looking into climate and you just see disputes and it gets politicized, et cetera. So I really appreciate that. Thank you so much.
Well, I want to add one word to what you just said.
Yeah.
You've been a gracious sister and a great host. And I think you and I have a lot to talk about besides this climate, although climate is really the only thing we're talking about.
Right,
right. But my perspective is that climate change is post-political. It simply doesn't matter whether you're a Democrat or a Republican, you're Trump or you're Biden, or you live in a country like Australia who has one sort of leader, or you live in Sweden that has another sort of leader. It just doesn't matter. Climate change doesn't care about your politics, right? No. And so this is post-political, and it's just bigger than anything that's ever happened in human history. I mean, that's the sad truth of what's going on right now.
Yeah. Okay, thank you, brother. Well, we'll connect soon again.
All right, sister. Thank you so much. You don't have to hang up right now, but we can talk in post, as they say.
Oh, right. We can go to our secret room.
All right, we'll go over here. That room. All right, see you later, sister.